Another explanation that I've been asked to give is we filled the displacer up with 17 bar of nitrogen, but it still doesn't behave as we were expecting it to. The nitrogen side is only half the story. Of course, the other side is the fluid side and how that is working through the displacer. So we'll have a look at this displacer here that was new old stock, but it was new old stock that failed very quickly because it all lost its nitrogen in the nitrogen side. So it failed within a few miles of actually being fitted to the car. Again, it's a Metro unit, RNK 10002. It's a Metro unit. Take that off there. And as we can see, the diaphragm on this one is actually completely split. We look inside, we can see the baffles here. So the fluid actually fills the underside of this diaphragm. Well, it would if it was in one piece. So we can see these baffles here allow the fluid to come through. If we take it apart further, we can see the damper valve assembly. So here's the damper valve assembly. That's a bit of explanation. There's a feed hole directly through. I'm not sure we can see that goes all the way through there. But, that's a pilot hole there, which allows the fluid to always flow from the bottom fluid side to the top fluid side. And here we can see some spring valves here that, as you go over a bump, allows the fluid to actually flow through quicker. So if we pop that open there, as you go over a bump, the fluid pushes that open and flows through. Now on the downward stroke, same thing again, we got some spring valves here. So as the fluid gets pushed back down again, it opens the valve, lets the fluid. So the fluid goes up and down, being held by the nitrogen side. So very nice unit. I'll now show you a older unit and what they look like after they've seen a bit of corrosion. So here we have an older unit, same thing here. If we're interested, we can see the original seal rivet and the nasty little points on there. And we can actually see on this one here the scarring. If you can see there's actually scarring on the diaphragm. It's not actually punctured, this one, but it's actually started to scar up. So as that diaphragm lifts, because there's no nitrogen pressure in this side, the fluid forces it up and it forces it against the this seal rivet. But interestingly, if we look at the inside of it, as we can see, corrosion. And this corrosion obviously stops the fluid flowing through. So if the fluid can't flow through and push against the nitrogen side, you don't get any springing. So we've got heavy corrosion here stopping the flow. But if we look at the damper assembly here, look at the state this is in. So we can't actually see a pilot hole through there at all. So if you were trying to fill this, it would probably lock out at whatever pressure. But in service, these little spring valves here, the flat valves, are not going to operate effectively. You can see the amount of rust on here. We have a look inside the unit as well, if we can try and get a view inside. Maybe a bit more light on there so we can get some more light in there and show the rust. Oh, that's a good view there. You can also see the formation of the rust, and of course that rust will slowly work its way through the and you'll lose the fluid seal, which is why you'll get fluid started to leak around this joint here. This is why when you actually fill a displacer unit back with fluid, it's essential you vacuum the whole system out, so you've got rid of all the air, therefore you've got no oxygen to cause this level of corrosion. Right, so the displacers are full of rust. Is there anything we can do about it? The derusting process I use basically is to put a general derusting liquid into the displacer, but actually draw it into the top half so we can actually get through all this rust here and actually get to the damper valve assembly. I've been testing this particular fluid for some years now. This sample here, which is a sample of the rubber part of the displacer, actually went in for 10 days on the 3rd of the 2nd 2016, was in for 10 days, dried off, and I then keep a regular check of that to see whether it's distorted or changed compared to the control piece, which is another piece of the rubber diaphragm here. And this piece here has actually been in for the, it's actually submerged for that time, although I keep on having to top it up, but that's actually been submerged for a number of years. And like it says on the tin, it doesn't actually seem to make any difference to the rubber compounds in the displacer. So what I'm going to do now is actually submerge these parts in the derusting material, and we'll see what happens over a period of time. And let that soak away. I'll fill this up. I'll keep on topping this up because essentially as this eats away at the rust, it'll actually go through to the other side of the sphere, but because the diaphragm on this one's intact, it'll actually hold it so it won't carry on running all over the bench. And we'll come back in a few days time and see what's happened. So the derusting fluid now has had 3 days to work. We put it in on the 31st of the 8th, it's now the 3rd of the 9th, so it's had 3 full days to work because it's gone nice and black in both areas. So we'll see what effect it's had on all that rust around the baffle area on this part of the displacer. Normally the displacer would be full of fluid, so it would get a lot more fluid, but for demonstration purposes we've only got a small amount of the derusting fluid, so that has now become actually saturated. So what we'll do is we'll have a look and see how far we've got, tip it all out, give it a bit of squirt clean, and then we'll put some more fluid in and we'll leave it for another 3 days to see the overall effect. Coincidentally, this displacer here has had derusting fluid in it now for about 7 days, so we'll also empty that out and see what the fluid's like inside. So we'll just tip this out now and have a look, see the effect on the rust. So it's nice and black, so it's actually saturated. And what's happened here is we start to, let's just spray some water over it so we can have a see. And normally what I would do is I'd fill this up with fresh water and pump it through a few times before I refilled it again with derusting fluid. But for just demonstration here, obviously this is nowhere near the 20 odd bar of fluid pressure I pushed through, but you can see we started to get somewhere. Bear in mind this was very, very corroded. So we actually start seeing some holes all the way through now, like we should do. See here, actually going through. So what we'll do is we'll leave that one, put that one to one side, then we'll top that back up with derusting fluid and we'll leave it for another 3 days. Let's have a look at the damper valve assembly. The box is slightly swelled, you get a bit of gas coming off of the derusting fluid. As you can see, all the stainless steel elements of it are now completely clean. Still some evidence of rust on there, but it just rubs away. So once this was full of water, if this was inside the displacer, full of water, and I started pumping 20 odd bar of fluid backwards and forward, which is what I normally do to flush it, this would come out not looking new, but looking a damn sight better than it was. So if you're any doubt as to whether or not the derusting fluid actually does anything, I think that's pretty conclusive. Now we can see the when you can see that now, you can actually see through the pilot hole. It's actually going all the way through now. Yeah. But again, what we'll do is we'll put that back in for a few more days and then we'll see what it's like. Put that to one side. Now we'll empty the displacer unit that's had the fluid in for about 7 days. As I say, normally during the process I swap the fluid about halfway through, and keep on shaking it and turning it. And I also put it under back into the clamp and actually pump the fluid right the way through the whole system, so it gets right the way through. So you can see that the blacker it is, the more iron oxide it's dissolved. Pretty much. Now, given that is how black that is, I know through experience there's still more rust to come out, because that's actually saturated the derusting material. So although that's had about 7 days, I've now flushed that through with clean water, and then I'd reload it and leave it for a few more days. But I don't know whether you can see the actual inside of the fluid connection pipe there. Not sure you can actually get that on there, but that's nice and clean. We'll have a look at that one again once I've put it in for another couple of days, and we can come back and have a look at that. As you can see from the state of that fluid, it's actually doing something. As you can see from the damper valve assembly, it's certainly attacking the rust. And even if it just softens the rust, when it's in the Hydragas fluid, is going backwards and forwards through the whole system, it will actually push it through. 6th and the 9th now, so they've both had 7 days. So we'll see what effect 7 days in the derusting fluid has made. Just tip that into there. Slight treacle. Trying to shake most of it out. You can see it started to break the rust down. You can actually see holes all the way through now. Now it's not perfect, but I would say it's good enough, because most of those holes are clear. I'll just give this a rinse now. Let's see, maybe see a little bit better. There we can see, I'd say 80–90% of those holes are clear. As I say, not perfect, but certainly a lot better than it was. Let's have a look at the damper valve assembly. This was already looking good after a few days, and now it's looking pretty good. Certainly operational. See, the spring steel dampers are nice and clean. All the holes are clear now, so that will operate as good as new. Let's give it a rinse, let it dry off. There, you can certainly see the hole all the way through now. In fact, every orifice, every path for the fluid is perfectly clear now, so that will function as new. It's a matter of interest, you want to look at what the residue is from the derusting fluid. As I say, it looks like treacle. If I just move it away, you can see the rust that it's pulled out. Some big lumps there in the flushing process. Pretty conclusive, I would say. So not only do you need to do the nitrogen at the top of the sphere, if your displacers have been sat around in storage for some time, I'd definitely recommend you have an internal derust.